everything's introduced, well, I can still say that I'm a postdoc at University of Waterloo. So let me spoil you the end. We found that on a trackpad, pointing without clutching is not faster than pointing with clutching. And it also causes more errors and requires more preparation. And now I'm going to explain you how we found that. So clutching is a pointing mechanism associated with relative pointing, for example with mice and trackpad. The user typically starts her pointing movement, but before she reaches her target, she has to reposition her finger or mouse, usually backwards, so that she can continue her pointing movements in the same direction. And this can happen more than once in a single pointing action. It's generally considered that clutching occurs either because the range of the input device is too small, or because the acceleration function is too slow. And it's also considered that clutching is detrimental to pointing performance, and especially to movement time, because the cursor does not move while the user repositions his finger or his mouse. So if he hadn't clutched, this time would not have been lost. However, we can make two observations. First, clutching mechanisms can be very different, from quickly lifting the finger to having to form specific hand postures to differentiate between pointing and clutching modes. Therefore, we can expect that some might be less detrimental than others, possibly to the point where they don't affect pointing time anymore. And this is why we chose to focus on the trackpad in this work as a starting point, since it's likely the device with the fastest clutching mechanism. And the second observation is that a typical trackpad with default settings allows you to go through the width of the display using less than the width of the trackpad. And this should mean that users don't need to clutch that often. Yet we observe informally, like in everyday use, that users do clutch, and they do clutch quite often, which would normally reflect a frequent suboptimal behavior. Now, the effect of clutching on performance has been discussed and theorized in the pointing literature, but it hasn't been evaluated alone. What we know for sure is that low gains and large pointing movements increase both the number of clutching and pointing time. But the actual relationship between the amount of clutching and performance has not been directly studied independently of these other factors. More precisely, higher pointing times have been observed when many clutches occurred, but the higher number of clutches was itself caused either by low CD gains or long pointing tasks, which could also have increased pointing time regardless of clutching. So in this situation, and in most pointing studies, it's difficult to know what actually caused the increase in pointing time and what effect had clutches on that increase of pointing time. So we took the question from the other end. Let's consider that not clutching, when feasible, is indeed optimal, as it is usually assumed. Our research question then becomes, what is the exact advantage of this ideal behavior of not clutching compared to normal user habits? And so we ran a control experiment to answer this question, our main factor being that whether we let participants point as they would normally do, or instructing them not to clutch at all. In our task, participants had to first bring the cursor inside a 10 millimeter wide starting circle here on the left, then click to start the task, bring the cursor inside the actual target, which is the green disk, and click again. And so in half the experiment, they were allowed to clutch as they saw fit, and in the other half, they were instructed not to. And finally, to facilitate clutch detection, clicking was performed using the physical button that's embedded inside the MacBook Pro trackpad, rather than with tapping. We also used 3 different cursor accelerations that correspond to existing speed settings in the Mac OS X trackpad preferences. And we used fits indexes of difficulty ranging from 2.2 to 7.3 bits in random directions. And we also checked that every task was feasible without clutching with every speed setting, especially the lowest. Participants have 15 trials to train in each condition, which we checked allowed their performance to stabilize. And finally, we had 12 participants in total. Okay, so a first result is that clutching occurs a lot under normal circumstances. We had an average of 1.24 clutches per trial in the clutch allowed condition. And interestingly, even the fastest speed setting goes almost 1 clutch per trial in average. Second thing is users had trouble performing clutchless one motion pointing movements. Clutching occurred in about 15% of trials in the condition where it was forbidden. This was, of course, significantly related to pointing difficulty, but not to acceleration settings. And these trials were removed from further analysis. Now to the actual comparisons. First, asking participants not to clutch caused almost twice as many pointing errors than in their normal behavior. And this may be because not clutching is indeed unusual. However, the effect is still there and should also be considered when advocating for not clutching. Second, we consider preparation time as the time between entering the starting circle and clicking it to start the task. And this time was usually essentially used to adjust the position of the finger on the trackpad before the task started, and especially in the no clutch condition. It took participants significantly more time to prepare their movement where they were forbidden to clutch, up to 1 second in average with the highest difficulties. And finally, we found that whether you consider preparation time or not, the clutch and no clutch trials had significantly equivalent, I insist, completion times. If you look at the plot on the right, both preparation time in green and movement time in blue were higher in average in the clutch forbidden condition, and that difference was enough to compensate for the time taken or lost clutching. So to summarize, under normal circumstances, users do clutch a lot with the trackpad, more than what would be predicted by existing models. And clutchless pointing, when feasible, remains harder to do. It causes more errors and requires more preparation, and overall provides no time improvement with the trackpad. So this is a general first result that we consider opens the question, or reopens the question of understanding the consequences of clutching. Implications of this work are first that clutching is a bit more complex than it's usually thought, especially considering existing models of clutching that systematically consider them detrimental to performance. Also, this could lead the way to define methods that relax the constraints on defining and calibrating transfer functions, because it's apparently not that important. Well, a little. So future works involves exploring these effects with other input devices and clutching mechanisms, such as mice or mid-air hand postures. We also want to explore the causes of clutching. Indeed, we've shown that increasing the effective range of the pointing technique is not the only element in play, and we expect that it will be related to psychomotor aspects of controlling large ranges of motor speed within small input areas and in small limited time. And from this knowledge, we plan and hope to propose models of pointing time that account for the fact that clutching is not necessarily detrimental to performance. And with that, I will take your questions. 감사합니다. Or not.
We have time for one decent-sized question.
So on my trackpad, when I'm trying to drag something, and if you get to the edge, it moves by itself. It continues to move, so it turns into a weight control joystick kind of thing.
Okay.
So there are these hybrid kind of behaviors on real touchpads. Is that part of what you looked at, or what you plan to look at?
Oh, okay. So no, really, what we looked at here was this initial study about something classic that has been studied a lot, and hoping to show that there's this maybe non-intuitive effect. I mean, this is clearly part of these other input devices and methods that we plan to consider. Thanks for the question.